In this video, we will be discussing rational functions and their graphs. The primary objectives of this video is to learn how to identify both vertical and horizontal asymptotes of rational functions. The first objective that we will be discussing is vertical asymptotes, how to find vertical asymptotes of rational functions. So the first thing that you are going to need to know is to factor and simplify the numerators and the denominators. Remember, when we factor, we use the generic rectangle and the diamond problem to do this. Any number that makes a denominator 0 will result in a vertical asymptote. And note that we write our vertical asymptotes as x equal and then whatever number resulted in making our denominator 0. Numbers that would make the denominator 0 but then cancel out with our numerator with the top will cause a hole in the graph. And this is something that we haven't seen before, but we'll take a look at an illustration of what a hole is on a graph. A hole is not clearly seen on a graphing calculator. We can only find it using our algebra skills. Let's go ahead and try a few examples. Please take some time and write down these examples because we'll be addressing each different possibility of a vertical asymptote, a hole, and then a rational function that results in no vertical asymptotes. So go ahead, pause the video, and copy down these examples. So as you can see in this first example on the left, I used my generic rectangle and diamond problem to factor my denominator, and when I did that, I got x plus 3 times x minus 3. Using the zero product property, I take each one of my factors, set them equal to 0, and solve for x. When I do so, I get x to equal -3 and x to equal +3, and those are our vertical asymptotes for this specific rational function. I note that I don't have any holes because x plus 3 and x minus 3 didn't cancel out with x in the numerator. And that leads us into this second example. We're going to see what happens when we can cancel within the numerator. In this second example, the denominator ended up being the same as the first, so I went ahead and factored and found my factors to be x minus 3 and x plus 3. So setting my denominators equal to 0, using the zero product property again, I get x minus 3 equals 0 and x equals 3 is my vertical asymptote. But realizing that the x plus 3 in my numerator cancels out with the x plus 3 in my denominator. And since it canceled out, I still end up having a hole happen at x minus 3, because if I were to plug in that -3 in for x, I still would end up dividing by 0, resulting in an error on my graphing calculator. So that's why we have a hole. Now if we were to graph this rational function, you wouldn't be able to see the hole, but it still would show up as an error on your table. So that'd be something that you should go and take a look at to see all the different places on the table of a graphing calculator where it would show you an error, whether that's going to be a vertical asymptote or whether that's going to be a hole. Now just quickly, if I were to take a look at my denominator of x squared plus 9, and if I were to set that equal to 0, I wouldn't be able to solve for x. So really there's no place that I can, or there's no number that I can plug in for x that would result in 0 happening in the denominator. So therefore, this one does not have a vertical asymptote. So I can plug in any number for x and get a result. So let's go ahead and take a look at these three rational functions taking a look at their graphs. So you can see the first example resulted in 2 vertical asymptotes on the left here. And then the one in the middle, it will show you right here where the hole is. But that's just because of a different graphing function or a graphing machine that was able to show you that. On your graphing calculator, again, a hole is not going to show up on a graph, but you'll be able to see the error happening in the table of your rational function. But you don't know if that error is a hole or if it is a vertical asymptote unless you do the algebra. And then lastly, that last example on the right that had no vertical asymptotes, here's the graph for it, and you can see again that there's no vertical asymptotes. Now we have reached the second objective for this video, in which we're going to identify horizontal asymptotes. Now we're going to use n and m to describe the degree of the numerator and the denominator. Now when we're talking about the degree of a polynomial of a rational function, we're looking at the highest exponent that's happening in the numerator and the highest exponent that's happening in the denominator. Now we have three different scenarios. If n is less than m, then y equals 0 is your horizontal asymptote, which basically says the x-axis is your horizontal asymptote. If the the degree in the numerator and in the denominator are the same, then you take the leading coefficients a and b and you divide them. A would be the leading coefficient of the numerator and b would be the leading coefficient of the denominator. If the denominator has a higher degree than the numerator, so if n is greater than m, then no horizontal asymptote exists. Okay, so these would be the three different conditions to find a horizontal asymptote. So let's go ahead and take a look at some examples. Again, I'd write this down just so we can refer back to it in the future. So taking a look at this first example, finding the horizontal asymptote, we're 4x divided by 2x squared plus 1. So if I were to look at the highest degree in the numerator, that would be 1. And the highest degree of the denominator is 2. Okay, because I have a squared or a quadratic in the denominator and I have a linear in the numerator. So since n is less than m, I result in a horizontal asymptote happening at y equals 0, or the x-axis. This second example, I have n equaling 2. I have m also equaling 2. And since n equals m, therefore I need to take the leading coefficients, 4 divided by 2, to find the horizontal asymptote. So y equals 4 divided by 2, or 2. So my horizontal asymptote would be at y equals 2. And then lastly, n is 3, m is 2. Okay, I have a cubic in the numerator and a quadratic in the denominator. Since n is greater than m, I have no horizontal asymptotes. So let's go ahead and take a look at these three functions, what their graphs look like, so we can see where those horizontal asymptotes are. With the first one, we said that the y-axis or the x-axis is the horizontal asymptote, and you can see as my graphs approach the x-axis, they're getting very, very close to it, but they're not going to end up touching it. And then in the second example, we calculated the quotient between our leading coefficients, 4 divided by 2, and found that our horizontal asymptote is y equals 2. And then the last one, we said no horizontal asymptotes. This graph is going to go on and on forever. Now the last thing that I do want you to be reminded of is how to find x and y intercepts. Y-intercepts are easy just by plugging in 0 for x. Simplify using the order of operations of rational functions to find where that y-intercept is. Some rational functions, especially those that have two vertical asymptotes, have a very funky operation that's happening in between those vertical asymptotes, and you want to take a closer look at that. And helping you to do that would be to find that y-intercept. Another thing that you would want to possibly find are x-intercepts. And you're going to do this by plugging in 0 for y. But this one you're going to have to solve for x algebraically. You can't just simplify and get the answer like you can with y-intercepts. So just a few reminders on how to find x and y-intercepts. And then there are just a couple of practice problems that I'd like you to do to definitely reference back to your notes. So the first problem I'd like you to take a look at is finding the vertical asymptote for the graph of the rational function f of x equals 4x squared divided by x squared minus 16. Again, I'm asking you to find the vertical asymptotes for this rational function. The second one that I'd like you to try is finding a horizontal asymptote for the graph of the rational function f of x equals 4x squared divided by x squared minus 16. Okay? Be careful on how you write your horizontal and vertical asymptotes. That's very important. And then lastly, just one more, finding a horizontal asymptote. Again, but a new function, 3x to the third divided by x squared minus 36. Again, be very mindful of how you write your horizontal asymptotes. Please please fill out the Google form that you will find in your Google Classroom following this video to place your answers. I will see you soon.